YParameters, otherwise called as short circuit admittance parameters. So here in this video I am going to discuss about the theory part of YParameters. So first point is general block diagram of two-port network. So this is a two-port network. It has two ports. So voltages and currents of port 1 are V1 and I1, and port 2 voltage V2, current I2. And here we have to get Y parameters. So first we have to get Y parameter equations. So second point is Y parameter equations. So Y parameter equations means port currents as a function of voltages. We have to write equations as the port currents as a function of voltages. I1, I2 as a function of V1 and V2. So I1 equal to Y11 V1 plus Y12 V2, equation 1. And I2 equal to Y21 V1 plus Y22 V2, equation 2. So here Y11, Y12, Y21 and Y22 are Y parameters, and Y11 is input driving point admittance, Y22 is output driving point admittance, Y12 is reverse transfer admittance, Y21 is forward transfer admittance. So solving for Y parameters. So here we solve for Y parameters by taking voltages 0. So port 2 voltage 0. If you take port 2 voltage 0, that is V2 equal to 0, we get Y11 and Y21. And by making port 1 voltage 0, that is V1 equal to 0, we get Y12 and Y22. So here solving for Y parameters, for V2 equal to 0, equation 1 becomes I1 equal to Y11 V1, which is equal to Y11 equal to I1 by V1 mos. So similarly equation 2 becomes I2 equal to Y21 V1. So from that one Y21 equal to I2 by V1 mos. So similarly if you make V1 equal to 0, for V1 equal to 0, equation 1 becomes I1 equal to Y12 V2. So from that Y12 equal to I1 by V2 mos. So equation 2 becomes I2 equal to Y22 V2. From that one Y22 equal to I2 by V2 mos. So Y parameters are also called short circuit admittance parameters because each time to get this Y parameters we are making voltage 0, either port 1 voltage 0 or port 2 voltage 0. So that's why it is short circuit parameters. So again short circuit admittance parameters. So why it is called as admittance parameters means, so if you look each parameter, here it is a voltage to current ratio, voltage to current ratio. So that's why they are called as admittance parameters. Now based on the Y parameters, we have to comment on the whether the given two-port network is reciprocal or not, or symmetrical or not, like that. So first let us look into this reciprocal network. A two-port network is called reciprocal if the short circuit transfer admittances are equal. That is, if Y12 equal to Y21, a two-port network is reciprocal. If Y12 equal to Y21, the given two-port network is reciprocal. And the second point is networks containing resistors, inductors and capacitors are generally reciprocal. So by seeing the network also we can say whether the given two-port network is reciprocal or not. If the two-port network has passive elements, that is resistors, inductors and capacitors, and linear elements, so then we can say the given two-port network is reciprocal. If the given there are any dependent sources in the two-port network, that is a non-reciprocal network. So based on the parameters, Y parameters, if Y12 equal to Y21, the given two-port network is reciprocal. So networks containing resistors, inductors and capacitors are generally reciprocal. Networks having dependent sources are generally non-reciprocal. So similarly symmetrical networks. A two-port network is called symmetrical if the short circuit driving point admittances are equal. That is, if Y11 equal to Y22, a two-port network is symmetrical. So based on the Y parameters, if Y11 equal to Y22, a given two-port network is symmetrical. So after that, Y parameter equivalent circuit. So this is the Y parameter equivalent circuits. So we are drawing a diagram by satisfying the Y parameter equations. So Y parameter equations, if you look into the Y parameter equations, so these are the Y parameter equations. So by So we are drawing a diagram to satisfy this equation 1 and 2. So here I1 equal to y11 v1 plus y12 v2. So this is a current and this is a current. So similarly I2 equal to y21 v1 plus y22 v2. So sum of two currents equal to current I2. So here I1 equal to y11 v1. So y11 v1 is a one current. y11 v1 is one current. y12 v2 is a dependent. So already v1 is there here. If you multiply this v1 with y11, we get one component of I1. So I1 has two currents. So one is y11 into v1. So second current is y12 v2. So v2 which is related to port 2. So that's why to satisfy the term we are taking a dependent current source whose value is y12 v2. So similarly from port 2 side v2 equal to I2 equal to y22 v2. So already we have v2. So if you multiply that v2 with y22, we get one current of I2. So IT has two currents. One current is y22 v2 and second current is y21 v1. So to satisfy this current v1, because v1 belongs to port 1, so we are going with dependent current source whose value is y21 v1. So sum of these two branch currents, this current and this current is I2. So in port 1, so sum of this current, this branch current and this current is I1. So here, as in Z parameters, we are able to draw T equivalent circuit. For the if the two-port network is reciprocal, we can draw, if you know Z parameters, we can draw T equivalent circuit. So similarly, if you know Y parameters and the given two-port network is reciprocal. So if the given two-port network is reciprocal and if you know the Y parameters of that two-port network, we can draw pi equivalent circuit. So pi equivalent circuit. A reciprocal network may be modeled by its pi equivalent circuit. Like this. So YA, YB, YC are the admittances of pi equivalent circuit. So V1 and V2, I1 and I2 are port voltages and port currents. So here we have to get this YA, YB and YC as a function of Y parameters, because if you know Y parameters, then we can draw a pi equivalent circuit. So here applying KCL at node 1. So this is node 1. So KCL at node 1 equal to, so three currents are associated at node 1. So I1, current in this branch and current in this branch. So KCL at node 1, I1 equal to YA V1 plus YC I1, so YC V1 minus V2. If you take this as a V1 voltage, so voltage from this node to this node is V1, voltage from this node to this node is V2. So voltage across this two nodes is V1 minus V2. So here we can write I1 equal to current in this branch is YA V1 and current in this branch is YC V1 minus V2. So if you write all V1 terms at one place, I1 equal to YA plus YC V1 minus YC V2. Taking this as the third equation. And similarly, if you write KCL at node 2, so this is the node 2. If you write KCL at node 2, I2 equal to current in this branch plus current in this branch. So current in this branch is YB into V2. So I2 equal to YB into V2 plus YC. Current in this branch but in this direction is YC into V2 minus V1. YC into V2 minus V1. So voltage across this branch is V2 minus V1 with respect to this node, and admittance is YC. So current in this branch is YC into V2 minus V1. So I2 equal to YB V2 plus YC V2 minus V1. So writing all V1 terms at one place and V2 terms at one place, I2 is equals to minus YC V1 plus YB plus YC V2. Now comparing equation 1 with equation 3 and so equation 1 with equation 3, we get Y11 equal to YA plus YC and Y12 equal to minus VC. So similarly comparing equation 2 with equation 4, we get Y21 equal to minus VC and Y22 equal to YB plus YC. So finally what is YA, YB, YC in terms of Y parameters is YC equal to YC equal to minus Y12 which is equal to minus Y21, and YA equal to Y11 plus Y12 and YB equal to Y22 plus Y21. So this is the theory part of Y parameters.